SP Smart School. Dear students, in my previous lectures, we discussed about the allied angles and trigonometric formulas, and we did the application of those allied angles and the trigonometric formulas in finding the general solution of the trigonometric equations. We want to proceed further to make use of those formulas which we discussed last time. So, here the problem is find sin x by 2, cos x by 2 and tan x by 2 when tan x is given to be equal to minus 4 by 3 and this angle x lies in the second quadrant. In second part we have cos x equal to minus 1 by 3, x lies in third quadrant, and C part is sin of x equal to 1 by 4 when x lies in the second quadrant. Well, in this case, in the first part here we have tan x equal to minus 4 by 3 and x lies in the second quadrant. When we say that x lies in the second quadrant, this means the value of x lies between pi by 2 is less than or equal to x, less than or equal to pi. Here in this case, when we say x lies in the third quadrant, that means in third quadrant the magnitude of the angle will be x will be pi less than or equal to x less than or equal to 3 pi by 2. Well, in the third case, when x lies in the second quadrant, we have the similar interval as pi by 2 is less than or equal to x less than or equal to pi. This is the limit of the second quadrant. Well, to add, I can explain here, this is x axis, this is x dash, y dash. Our initial line is OX. In the first quadrant, the magnitude of angle will be from 0 to 90 degree. In second quadrant, it is 90 degree to from here till here, 90 degree to 180 degree. In third quadrant, we have 180 degree to 270 degrees, and in fourth quadrant this is 270 degree to 360 degree. Well, you can write in radians also like this. Well, students, here we have an angle x, tan x. We need to find out x by 2, sin x by 2, cos x by 2 and tan x by 2. In each of these cases, whether it is sin x by 2 or cos x by 2 or tan x by 2, we need to find out first value of cos of x. In each case, and then we shall use the formulas related with cos x. Now, tan x is minus 4 by 3 and x lies in the second quadrant. We have, this is your y axis, this is x axis, angle in the second quadrant will be like this, and you have this right triangle P M, this is right angle O M P. When tan x is minus 4 by 3, tan x means perpendicular over base. This is minus 4 by 3. PM is 4 units and this is 3 units. Since it lies in the direction of OX dash, we shall take with negative sign here and try to find out hypotenuse OP by using Pythagoras theorem, PM square plus OM square under the root. This is 16 plus 9 under root, so this is 25 under root equal to 5 units. So, this is 5 units. So, therefore, cos of x equal to base upon hypotenuse 5. And of course, here x lies in second quadrant where the value of cos x is negative. Now, having found out cos x equal to minus 3 by 5, for finding tan of x or finding sin x by 2 using 2 sin square x by 2 equals to 1 minus cos of x. This is a formula which we have already discussed under the heading of this trigonometric ratios of submultiple angles, or 2 sin square x by 2 is 1 minus 3 by 5. Minus and minus becomes plus here, because cos x is minus 3 by 5, or 2 sin square x by 2 is 5 plus 3, 8 upon 5, or sin square x by 2 equal to 4 by 5. Divide both sides by 2, and sin of x by 2 is square root of 4 by 5, of course with plus minus sign. But we take sin x by 2 is equal to plus 2 upon root 5, because square root of 4 is 2. This is pi by 2 pi. Since we want x by 2, or divide throughout by 2, pi by 4 less than or equal to x by 2 less than or equal to pi by 2. So, here in this case we observe that this angle sin x by 2 or x by 2 lies between 45 degree and 90 degree, which is in the first quadrant. So, sin x by 2 is positive in the first quadrant. Then we need to find out cos of x by 2. Now, use the formula again, 2 cos square x by 2 is 1 plus cos x. This is the formula x. Cos x is this value minus 3 by 5. Substitute the value here is equal to 1 minus 3 by 5, and if you simplify we get cos square x by 2 equal to 2 upon 5, and cos of x by 2 to minus under root 2 upon under root 5. Why negative? Why negative? Reason being, no, it will be positive. Then tan x by 2. Tan x by 2 is sin x by 2 divided by cos of x by 2. Now sin x by 2 is here, 2 upon root 5 upon cos x by 2 is under root 2 upon root 5. If you simplify, you get the result as under root 2. Or you can write here under root 2. Well, using the same principle, we have cos x equal to minus 1 by 3 and x lies in the third quadrant. Let us find out sin x by 2 first. 2 sin square x by 2 equal to 1 minus cos of x or 2 sin square x by 2 to 1 plus 1 by 3, or this comes out to be 4 by 3. Cos x is minus 1 by 3. Minus and minus will be plus. Sin of x by 2, of course square of this equal to 2 upon. Therefore, sin x by 2 is 2 under root upon under root 3. Now let us see whether it is positive or negative. Pi by 2 less than x less than 3 pi by 2, divide throughout by 2. Pi by 2 less than equal to x by 2 is then equal to 3 pi by 4. That means in the, this lies in the second quadrant. Where sin x by 2 is positive. See, x is given to be in the third quadrant, pi less than or equal to x less than or equal to 3 pi by 2. We need to find here that in which quadrant does x by 2 lie. Divide throughout by 2. This is between 90 degree and 135 degree, which is in the second quadrant. Now, cos of square x by 2 twice of this equal to 1 plus cos of x. Cos x is minus 1 by 3 and this is 2 by 3, or cos square x by 2 equals to 1 by 3. Therefore, cos of x by 2 is equal to minus 1 by root 3. Why? Explanation is x by 2 lies in second quadrant when x lies in the third. Therefore, tan of x by 2 sin x by 2 cos of x by 2, which is equal to sin x by 2 is under root 2 upon under root 3, and this is cos minus 1 by under root 3. If you simplify, this is minus root 2, and of course tan x by 2 is negative in second quadrant. Proceeding in the same way, here sin x is equal to, here sin x equal to 1 by 4. we need to find cos x. So, this is under root 1 minus sin square x, and this is second quadrant, it is negative cos x. So, it is minus under root 1 minus sin x is 1 by 4, 1 by 16, or this is equal to minus 15 under root by 4. So, we want to find 2 sin square x by 2, use 1 minus cos of x, sin square x by 2 twice of this equal to 1 plus 15 under root by 4. If you simplify, 4 plus 15 under root by 4, and sin x by 2 is under root 4 plus 15 under root upon 2 root 2. Next, cos of x by 2 is 1 plus cos of 2 cos square x by 2, 1 plus cos x, or this is cos x is minus this. So, this is 1 minus 15 under root by 4, and cos of x by 2 will be minus 4 minus 15 under root upon 2 root 2. Well, we move a step further to find the value of, say, tan of 15 degrees, and then tan of pi by 8, or we can write this as tan of 22.5 degrees. Now, in this case it is simple to find out tan of 15 degrees. Tan of 15 degrees can be written as tan of 60 degrees minus 45. Even you can write down 45 minus 30, selecting these two angles in such a way that we know the trigonometric ratios or values of tan of 60 degree and tan of 45. Now, making use the formula tan of A minus B, this is equal to tan of the first angle minus tan of the second angle, or over 1 plus tan of 60 degrees to tan of 45. We have done tan A minus B, tan A minus tan B upon 1 plus tan A tan B. A stands for 60 degree and B stands for 45 degrees. So, tan 60 degree is root 3 minus tan 45 is 1 over 1 plus root 3 into 1. So, naturally we can write down root 3 minus 1 upon root 3 plus 1. For finding the value of now tan of pi by 8, the procedure is, let us assume that x equal, let x stands for pi by 8. So, therefore, 2x multiply both sides by 2 is pi by 4. Making use of the formula, using tan of 2x equal to 2 tan of x divided by 1 minus tan square x. Here, or tan of 45 degrees, pi by 4, 2x equal to pi by 4, and let tan x stands for y, that is tan of pi by 8 stands for y. So, this is 2y divided by 1 minus y square. Tan 45 is 1 equals to 2y upon 1 minus y square, or multiply crosswise we have 1 minus y square equal to 2y, or therefore y square plus 2y minus 1 equals to 0. This is a quadratic equation in y. Make use of the quadratic formula for solving the value of y. So, y equal to minus b plus minus root b square 4 minus 4ac plus 4 whole divided by 2a, 2 into 1. So, this is minus 2 plus minus 8 root upon 2. This is 2 plus minus 2 root 2 upon 2. If you take out 2 common, this will be minus 1 plus minus root 2, 2 will cancel. So, we get the value of y as y equals to minus 1 plus root 2 and minus 1 minus root 2, or taking tan x by 2. If you remember, this is tan x equal to root 2 minus 1. Now, tan of x is not equal to minus 1 minus root 2. This being a negative value, x equal to pi by 8 lies in first quadrant, where tan of pi by 8 is positive, that is root 2 minus 1. This is how we find the value of tan of pi by 8 or tan of 22.5 as root 2 minus 1. Well, next we have another problem where we make use of the formulas as cos of, this is proof that cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x equals to minus root 2 sine of x. So, you take the left hand side. Left hand side is cos 3 pi by 4 plus x minus cos of 3 pi by 4 minus x. Use the formula cos c minus cos of d as minus 2 sin c plus d by 2 sin of c minus d by 2. Treat this as c and this as d. So, we have minus 2 sin c 3 pi by 4 plus x plus 3 pi by 4 minus x into sin of c minus d, that is 3 pi by 4 plus x minus 3 pi by 4 plus x. Of course, divided by 2, here also divided by 2. This x cancels with this. So, 3 pi plus this, if you simplify, this will be 2 sin of 6 pi upon 8, 4 into 2, and here this will cancel out and this will be sin of 2x upon 2, 2 gets cancelled. So, this is 2 3s are and 2 4s are. Sin 3 pi by 4 means sin of 135 degrees, which is sin of 180 minus 45 in second quadrant, and this is sin of 45 degree, whose value is 1 by root 2. So, this is minus 2 sin of 3 pi by 4, that is 1 by root 2 into sin of x here. This root 2 gets cancelled with this. So, we have minus root 2 sin of x, and this is your right hand side. Here we are going to prove cot 4x into sin 5x plus sin 3x equal to cot x into sin 5x minus sin 3x. Collect the terms of cot of 4x upon cot of x and take this sin terms on the right hand side, sin of 5x minus sin of 3x upon sin of 5x plus sin of 3x. So, take the right hand side. This is sin of 5x minus sin of 3x divided by sin of 5x plus sin of 3x. Again we make use of the formula sin c minus sin d in the numerator, which is 2 cos c plus d by 2 sin c minus d by 2. And in the denominator we make use of the formula sin c plus sin of d. This is twice sin c plus d by 2 cos of c minus d by 2. So, well, this is twice cos of c, c stands for 5x plus d divided by 2 and sine of 5x minus 3x divided by 2. In the denominator we have 2 sine of c plus d upon 2 cos of c minus d upon 2. This 2 gets cancelled with this, or we have cos of 4x, 5 plus 3 8 divided by 2 and sine of 2x 5x minus 3x x upon sine 4x into cos of x. If you combine this cos over sine, it is cot 4x. If you combine this, it is tan of x. And now here, to make it left hand side, we change this in terms of cot x, and this is left hand side. Next we have problem like this: sine square 6x minus sine square 4x equal to sine 2x sine of 10x. And a similar type of question B is cos square 2x minus cos square 6x equal to sine of 4x. In the first part, this is solution to the first part. Take the left hand side. This is sine square 6x minus sine square 4x. Again we make use of the formula that sine square a minus sine square b, this is equal to sine a plus b multiplied by sine of a minus b. So, a in this case 6x sine of a plus b into sine of a minus b, and this is sine of 10x into sine of 2x, and this is right side. Now, we have the solution of b part. This is left hand side cos square 2x minus cos square 6x. Well, we do not have the standard formula for using cos square a minus cos square b, but we have sine square a minus sine square b as sine of a plus b into sine of A minus P. So, taking this, we change cos square 2x as 1 minus sin square 2x minus 1 minus sin square 6x. And if you open the bracket, this 1 and 1 gets cancelled, we have sin square 6x minus sin square 2x, and you can make use of the formula mentioned above. So, this will be sin of A plus B multiplied by sin of A minus B. So, this comes out to be sin of 8x into sin of 4x, and this is right hand side. We take up any relation between 3x minus 2x equal to x. We could take up the relation as 3x minus x equal to 2x, or 2x plus x equal to 3x. Any one of these relations, this or this. And then apply tan to both sides. Apply tan to both sides. So, this is tan of compound angle 3x minus 2x equal to tan of x. On the left hand side, we apply the formula tan of A minus P, or this is tan of the first angle minus tan of the second angle divided by 1 plus tan of first angle into tan of second angle equal to tan of x. Multiplying crosswise, or we have tan of 3x minus tan of 2x, multiply the denominator of this by tan x, this will be tan of x plus tan of 3x, tan of 2x, and then tan of x by crosswise, or tan 3x minus tan of 2x, bring this tan x to this side, minus tan of x equal to tan of 3x, tan of 2x, and tan of x. Or to write the result in this form, we transpose both the sides, interchange both the sides. So, the tan 3x into tan of 2x tan of x equal to tan of 3x minus tan of 2x and minus tan of x. So, this is the solution of this. Coming to the part second B, we have the relationship between x, 2x and 3x along with cot. So, we write here 2x plus x equal to 3x. Apply cot. So, cot of, this is B part, cot of 2x plus x equal to cot of 3x. Apply the formula cot of A plus P, or cot of A cot of B minus 1 upon cot of B plus cot of A equal to cot of 3x. So, multiply crosswise, or we have cot of 2x, cot of x minus 1 equal to cot of 3x into cot of x plus cot of 3x into cot of 2x. So, you can rearrange the terms and write the result in the desired form. Here it is cot x into cot of 2x, this term, minus, bring this term to the side, cot 3x cot of 2x minus cot of 3x into cot of x equals to 1. This is the solution of the second part. Another problem is a typical one where cos square x plus cos square x plus 3 x plus pi by 3 plus cos square x minus pi by 3, and we need to prove that this is equal to 3 by 2. So, whenever there is cos square x, cos square alpha, cos square beta, or sin square x, sin square beta, sin square alpha, we make use of this formula 2 cos square a equal to 1 plus cos of 2a. So, take the left hand side and create 2 as coefficient of cos square x, 2 cos square x plus pi by 3 plus 2 cos square x minus pi by 3. If you take out 2 common from this bracket, it will get cancelled with this. Now, make use of this formula. If it is a, this will be 1 plus cos of 2a. So, this is 1 by 2 into this is 1 plus cos of 2x plus, now for this we shall write down as 1 plus cos of twice of this angle, that is 2x plus 2 pi by 3 plus, for this we shall write down 1 plus cos of 2a, twice of this angle, 2x minus 2 pi by 3, and close the bracket. This one and this one when added will give you 3 plus cos of 2x plus, within bracket we have cos of 2x plus 2 pi by 3 plus cos of 2x minus 2 pi by 3. Here at this stage we shall make use of the formula cos of a plus b. Treat 2x as a plus cos of a minus b as 2 cos a cos b. Treating this 2x as a, 2 pi by 3 as b, we have cos a plus b. Likewise, this is a minus p. So, this is equal to 1 by 2 into 3 plus cos 2x plus there will be twice cos of 2x into cos of 2 pi by 3. To find the value of this is cos 2 pi by 3 now, which otherwise you can say cos of 2 pi upon 3 can be written as pi minus pi by 3. In second quadrant it is negative cos of pi by 3, which is minus 1 by 2. So, this is 1 by 2 into 3 plus cos of 2x plus 2 cos of 2x and minus 1 by 2. This 2 and 2 gets cancelled. So, we have 1 by 2 to 3 plus cos of 2x minus cos of 2x. Minus 1 into cos 2x will give this and this gets cancelled and the final result is 3 by 2. Two cos of pi by 13 into cos of 9 pi by 13. Plus cos of 3 pi by 13 plus cos of 5 pi by 13 equals to 0. For establishing this result, we take the left hand side and write the 2 cos of 9 pi by 13 cos of pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. Now, note this, the larger angle I have written first, the smaller angle pi by 13 later on, it saves one step while using the formula. So, here changing this product by into sum as 2 cos of A cos of B equals to cos of A plus B plus cos of A minus B. So, this is equal to cos of A 9 pi by 13 plus B pi by 13 plus cos of 9 pi by 13 minus pi by 13. Keeping these two terms as they are. Now, I can write down this as cos of 10 pi by 13, okay. Pi plus 9 pi 13, we have the same denominator here, plus cos of 8 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. Now, 0 on the right hand side gives us a hint that all these terms must cancel. To cancel these all terms, we have here the difference of 3, 10 and 13. Here is the difference of 3 and 13 as 10. Either you change this or this as cos of pi minus 3 pi by 13. If you take the LCM as 13, 13 pi minus 3 pi is 10 pi. Likewise, cos of pi minus 5 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. So, this is equal to minus cos of 3 pi by 13 minus cos of 5 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. Using cos of pi minus theta in second quadrant minus cos of theta. Here again we are making use of the line angles. These terms gets cancelled and the result is 0. Another problem, we have proved that cos x minus cos y and square of this plus sin x minus sin y square of this, and this is 4 sin square x minus y upon 2. Take the left hand side. Use the formula cos c minus cos t minus 2 sin c plus d by 2 into sin of c minus d by 2. Plus 2 cos c plus d by 2 sin of c minus d by 2. Square it and take out 4 sin square x minus y by 2 common. So, we have sin square x plus y by 2 plus cos square x plus y by 2, or this is 4 sin square by 2 and this is 1 equal to right hand side.